So the idea of a robotic or self-driving car has been one of these ideas that's been about 20 years in the future, ever since about 1939. So it's been pretty consistent up until recent years, and I think starting with the DARPA Urban Challenge and Grand Challenge, where they said, okay, let's have a competition, and everybody bring your best stuff, and we'll see how close these vehicles are to reality. It sparked people's attention. There's been a lot of efforts at Google and more recently at the auto manufacturers as well, taking this extremely seriously and asking the question, okay, how far away are we from starting to get these technologies into a product? There's obviously been a lot of work with driver assistance systems, so things like adaptive cruise control that will keep you a safe distance from the vehicle in front, lane keeping assistance that will keep you in the lane. And so in some ways you can march towards this autonomous technology by taking the systems that are already out there on the road and beginning to stitch them together. You'll see how hard it brakes in just a second as the front of the car pitches down there and it begins to brake while cornering. This is something that's very difficult for humans to manage that process, but the car does it very well. You can see the car here is also finding a way to sort of straighten out the road. The road is curving, but it finds the straight path, the shortest distance, and then puts itself on the outside of the turn, to the inside, to the outside again, using up all of the space that it can. Now, the next turn here is actually something that's a little bit tricky. There's not a lot of visual references as to how to take the best racing line around here. So the car is able to find that. I actually had a huge problem with this turn when I was driving the track until I followed the car, and then I actually learned the correct racing line. Now here we're going down the straightaway, and basically the car is floored. We have nobody in it at this point, so the car gets up over 115 miles an hour, and the brakes got a little hot. So as you see, it starts to brake and oops, steers a bit too much, and swerves to get back on the track. If you see it from the inside now, you'll see in fact what the car is doing. Here we are driving down the straightaway. This is the interior view of that last corner. You see the car starts to move to the outside to make the most room, steers in, then has to correct for this skid, but gets right back on the line. And I think that video sort of gives a good impression of what it is that we're going for here.
How does it compare to a human driver if you were to be able to race the two? Which would be
well,
better?
in fact, actually, we have compared with the president of the track, and at this point, we're a little bit slower. Now, our path around the track is pretty similar, and I think actually that's a really interesting thing. We can let computers chug on this question of how do I find the fastest line around the track, and then you put a human who's very skilled in the car and they go out and they find it. In fact, sometimes they can find it more quickly than the algorithm can chew over this. So there we're at about par with the human driver. What the human drivers do amazingly well is to consistently feel out the limits of the car and push it just a little bit further. So that is in fact where they have an advantage, and we're trying to learn from them now to continue to improve the advantage. So we've got a margin right now of a few seconds around this 3-mile track, and we're working to bring that down now.